talk about NTP network time protocol. This is called Infrastructure Services Part 2. What we're really just going to discuss for a couple minutes is NTP, the network time protocol. Time's important because you need to know if something happened, when it happened, what time, and how do the other devices relate, what was going on with them at those times. So time becomes a really big deal. And those of you who manage or work in Microsoft networks, Active Directory won't even let you log in if you're more than 5 minutes out of time. So time, NTP-PORT 123, it's an application layer protocol, synchronizes the clock times on devices in a network by exchanging time signals. And we're going to go down. We show here an NTP server and an NTP client. Cisco routers can be either. We can configure it as the master so that it gives time to the clients on our network. It would get its synchronization from a quote reliable unquote time source, a master clock on the internet, for instance. So it works on the application layer of the TCP IP and the OSI models, sends periodic time requests to servers to obtain a server timestamp and adjust the client's clock based upon the server timestamp. That's a whole lot to say. Hey, we're going to ask this guy and he's going to send us the time, and we're going to adjust our clock so that our clocks here are all got the same time. And hopefully we're all going to have the correct time. We need to set time zones so that we know what's happening on everything all throughout the network on a standard time basis. Because we have NTP server, we may have a log server where the logs from all of the clients and maybe from different time zones are sent there. So it's important that they all have the same time and the correct time. Very important in the network because the timestamps on log messages generated by the different devices to help troubleshoot problems. NTP servers synchronize the time in all the clients to milliseconds. And when you're doing Cisco, when you're talking about time, always use the question mark to find out what the time is. It could be minutes, it could be hours and minutes, it could be seconds, milliseconds in this case. So not that we're going to configure it here, but it's configured to the millisecond. But when you're doing time, be sure you check to see what the time is and what the unit of time is. We can do authentication with these things. Can be configured to authenticate the NTP synchronization so that we don't get a rogue server in here that may change the time of some devices and others. Why would you do that? Because we may have access control lists that are time controlled. Who can do what? We may have certain actions that happen based upon a clock. So we need to have the time synchronized on all of our servers so that they can then carry out the configurations that we've done properly. NTP authentication is figured at the device, uses authentication keys to verify the time source. It's not going to be an extremely sophisticated authentication, but it does do authentication. We configure keys that will then allow the server to accept the time updates from the clients to accept time updates from the servers. Authentication keys that NTP server must provide or define with the NTP authentication key command at the server. The NTP trusted key command is used to validate the authentication keys. Client permits synchronization only after ensuring that the authentication keys are valid. If the authentication fails, the client does not allow time synchronization at the local clock and discards the NTP packet. So if we don't synchronize, it's not like the world ends, but we do not update using that server. Clients, those devices that receive the time, a Cisco device can act as a client. Devices that receive time updates from an NTP server. NTP server and IP address command is what we're going to use at the device to allow the local clock to synchronize with an NTP server. The IP address here is going to be the NTP server. So where are we going to get our time from? Where are we going to request our time from? The NTP server and then the IP address. Is entered, the IP address of the NTP server is available at the device, and the device is identified as an NTP client. What we also probably want to do is ping this IP address so to ensure that we have connectivity, because if we can't ping it at layer 3, we certainly can't communicate it with it at layer 7. The show NTP status displays the current status of the time synchronization. Devices in the network can act like peers and provide time synchronization to other devices. IP addresses for peer associations are statically configured on the peer devices to enable them. So what's saying is that clients can update clients with these things. And we have the show NTP associations. Displays other devices which a particular device is associated with. So NTP associations, where are we getting our information from? Which devices are we associating with? The NTP servers are Cisco devices that receive time from a reliable source and use that time to synchronize NTP clients. TIC, one of them still going, TIC.US Naval Observatory.Navy.mil might be a reliable time source. A metric called a STRATUM is used to indicate the number of servers that hops that lie between the servers and the time source. And I've got an image here after this slide that hopefully is going to shed a little light on what a stratum actually is. This is how far away the server is. Stratum 1 servers are directly connected to the time source, GPS, device, radio clock, or atomic clock, the devices that world time is based on. So Stratum 1 is directly connected to these things, and Cisco uses Stratum 2 to Stratum 15. Are synchronized with public NTPs, network time protocol servers in the internet. NTP server always checks the time reported by its time source. If it varies significantly, and they don't define what significantly is, from the NTP server's time, synchronization is not performed. It doesn't change. It does not change its time if it's too far out of time, because it just assumes that either that's wrong or there's something wrong with the clock itself, with the device itself. NTP relationships designated certain hosts as time servers can be established in the network. Enable the network devices to maintain accurate time even if the NTP server is down. To be established, they say NTP peer relationships, we talked about in the previous slide. The NTP master command sets a Cisco router or switch to act as the NTP server, because so it's the NTP master command tells it that it is a time server. The stratum levels, and again, is just how far away are we. We have the authoritative clock. The primary servers, Stratum 1 is directly connected to the clock. Stratum 2 are connected to the primary servers. 3 tertiary servers connected to the secondary servers on down the line. And Cisco was 2 to 15. So how far away is the server that we're using to synchronize our network with? And that's all a stratum is. So in NTP, we talked about the NTP, the Network Time Protocol, is an application layer protocol, uses port 123. 123. It synchronizes time. We had clients and servers. The clients get the time from the servers, obviously, and the servers can get the time from trusted, reliable time sources outside the network, and then they're used to update the devices on the network. Authentication is available in NTP if we want to configure it. Why would we do that? Time-based access control. If somebody comes in and has a rogue time master or sets up a situation so that it can give time to our devices, could change when the access control lists actually go into effect. So we had clients and servers. Servers gave time, clients got the time updates from the servers, and then we talked about the STRATUM, which is how far away a time server the server is that's giving us a time. How far away are we from the server? So with that, we'll do some demos on the things that we've talked about: DNS, DHCP, DHCP relay, and then network time protocol. See ya at the demos.